Dear students, we shall continue the properties of DTFT. Seventh property, modulation bar frequency domain convolution. Modulation bar frequency domain convolution property. Statement: if x of n has a discrete time Fourier transform x of e power j omega and h of n has a discrete time Fourier transform h of e power j omega, then y of n equals x of n into h of n has a discrete time Fourier transform y of e power j omega equals 1 by 2 pi into x of e power j omega periodically convoluted with h of e power j omega. This is the symbol for periodic convolution. What is the periodic convolution? I will explain. See, x of e power j omega, periodic convolution, what it means is x of e power j omega convoluted with h of e power j omega equals integration over from minus pi to plus pi. What is the period of x of e power j omega? 2 pi. What is the fundamental period of h of e power j omega? 2 pi. The upper limit pi minus lower limit minus pi gives you 2 pi. This integration is over one period of x of e power j omega and h of e power j omega. Normally, in convolution, the integral runs from minus infinity to plus infinity. In the first function, replace omega by beta. In the second function, replace omega by omega minus beta. Then integrate the product with respect to beta. This is how the periodic convolution shown in this bracket is done. Note that limits of integration is from minus pi to plus pi. It's not from minus infinity to plus infinity. The proof of this shall be done now. We know that y of e power j omega by definition is summation n equals minus infinity to plus infinity y of n into e to the power minus j omega n equal to summation n equals minus infinity to plus infinity. What is y of n? Y of n is nothing but x of n multiplied by h of n into e to the power minus j omega n. I call this as equation 1. Also, by definition, x of n equals 1 by 2 pi integration from minus pi to plus pi x of e to the power j beta e to the power j beta n d beta. This is nothing but a defining equation for finding inverse DTFT. Instead of omega, I have used beta. Because omega is a dummy variable, it can be replaced by beta. What I mean is, inverse DTFT equation is 1 by 2 pi integration from minus pi to plus pi x of e power j omega into e to the power j omega and d omega. Instead of omega, here we have got beta. Because both the integrals will give the same result. Omega is a dummy variable, it is replaced by beta. What I mean by dummy variable? Integral 0 to 1 x square dx is same as integral 0 to 1 y square dy. Both these integrals will give same result. Therefore, whether we have x inside the integral or y inside the integral, it is immaterial. Same logic is applied to these two integrals. This I call as equation number 2. Substituting equation 2 in equation 1, we get y of e power j omega equals this x of n is replaced by this integral. Summation n equals minus infinity to plus infinity 1 by 2 pi integral minus pi to plus pi x of e to the power j beta into e to the power j beta n d beta into h of n into e to the power minus j omega n. Interchanging the summation and integration orders, we get y of e power j omega equal to 1 by 2 pi integration from minus pi to plus pi x of e to the power j beta summation n equals minus infinity to plus infinity h of n into e to the power minus j omega minus beta into n. This is nothing but 1 by 2 pi integration minus pi to plus pi x of e to the power j beta summation n equals minus infinity to plus infinity d beta, please write here. Okay. Summation n equals minus infinity to plus infinity h of n into e to the power minus j omega n with omega replaced by omega minus beta. Then what we get? Then we get y of e power j omega equals 1 by 2 pi integration from minus pi to plus pi x of e to the power j beta. The summation stands for h of e to the power j omega and omega has to be replaced by omega minus beta. So this becomes 1 by 2 pi integration from minus pi to plus pi x of e to the power j beta into h of e to the power j omega minus beta d beta. This is nothing but periodic convolution, which is a dummy variable here, beta. Hence we can write this as 1 by 2 pi. This integral stands for periodic convolution of x of e power j omega and h of e power j omega. This completes the proof. Next I teach you a property which is also in the form of a theorem called Parseval's theorem. P-A-R-S-E-V-A-L as apostrophe S, Parseval's theorem. Statement I will give you. If DTFT of x of n is x of e power j omega, then the energy of the signal, x of n is summation n equals minus infinity to plus infinity, magnitude of x of n whole square equals 1 by 2 pi integration from minus pi to plus pi modulus of x of e power j omega whole square d omega. What is the implication of this theorem? The implication is, even when you know the signal in frequency domain, it is possible to find the energy of the time domain signal by performing this integration and then multiplying by the scalar 1 by 2 pi. The proof of this theorem requires a small understanding. Let me take a complex number, let us say x of n, let x of n be a plus jb, where a plus jb is a complex number. What is x conjugate of n? X conjugate of n is a minus jb. Therefore, what is x of n into x conjugate of n? Nothing but a plus jb into a minus jb. This is nothing but a square minus jb square. J square is minus 1, so that you get a square plus b square. This is nothing but magnitude of x of n whole square. So what is important is, magnitude of x of n whole square is nothing but x of n into x conjugate of n. This knowledge is required for proving the Parseval's theorem. So the Parseval's theorem proof will start now. E equals proof E equals summation n equals minus infinity to plus infinity modulus of x of n square equals summation n equals minus infinity to plus infinity x of n into x conjugate of n. I'll call this as equation 1. By definition, what is x of n? 1 by 2 pi integral minus pi to plus pi x of e to the power j omega into e to the power j omega n d omega. Definition of inverse DTFT of x of e power j omega. Taking complex conjugates on both sides. Taking complex conjugates on both sides we get x conjugate of n equals 1 by 2 pi integration from minus pi to plus pi x conjugate of e power j omega. When you do conjugation, plus j becomes minus j, e to the power minus j omega n d omega. This I will call equation 2. Substituting equation 2 in equation 1, we get E is equal to summation n equals minus infinity to plus infinity. In equation 1 is x of n, you replace by the right hand side of equation 2. 1 by 2 pi integration from minus pi to plus pi x conjugate of e to the power j omega into e to the power minus j omega n d omega into x conjugate of n. Interchange integration and summation orders. That will give you 1 by 2 pi integration from minus pi to plus pi x conjugate of e to the power j omega summation n equals minus infinity to plus infinity. So this is x of n. x of n. I have substituted, I told wrongly, I substituted for x conjugate of n because this is x conjugate of n. Please make this correction. So when I substitute equation 2 in equation 1, we are not substituting for x of n, we are substituting for x conjugate of n. Therefore this x of n remains unchanged. Summation n equals minus infinity to plus infinity, x of n into e to the power minus j omega n d omega. The summation stands for DTFT of x of n. So we get 1 by 2 pi integration from minus pi to plus pi x conjugate of e to the power j omega into x of e to the power j omega d omega. So this is nothing but 1 by 2 pi integration from minus pi to plus pi modulus of x of e to the power j omega whole square d omega. Very, very important proof. I'll explain this proof once again. E is equal to summation n equals minus infinity to plus infinity modulus of x of n whole square. This is nothing but modulus of x of n whole square. I'll write it as x of n into x conjugate of n. This is the defining equation for finding inverse DTFT of x of e power j omega. We take complex conjugates on both sides. X of n becomes x conjugate of n. X of e power j omega becomes x conjugate of e power j omega. This positive, in this exponential plus j becomes minus j. Substitute, replace this x conjugate of n by the right hand side of equation 2. X of n remains unchanged. That results in this equation. I am interchanging the integration and summation orders. That results in this equation. This summation gives the defining equation for finding DTFT of x of n. Therefore, it is nothing but x of e power j omega. X conjugate of e power j omega and x of e power j omega equals magnitude of x of e power j omega whole square. This completes the proof. These proofs you have to practice, otherwise you will get stuck in the examination. This requires at least 2-3 times preparation. With this, we now start problems on DTFT. First problem. Find DTFT of x of n equals a to the power n into u of n. Sketch amplitude and phase spectra. Spectra is the plural of spectrum. Spectra. Solution. X of e power j omega by definition is summation n equals minus infinity to plus infinity x of n into e to the power minus j omega n. Because of this u of n, the lower limit of summation will become 0. Hence, I will write we know that. Hence, x of e power j omega equals summation n equals 0 to infinity a to the power n into e to the power minus j omega n. U of n is 1. Please note, u of n is 1 for positive time, 0 for negative time. Hence, when you substitute the expression for x of n in this summation, the lower limit of summation becomes 0 and u of n becomes 1. U of n becomes 1. This implies x of e power j omega equals summation n equal to 0 to infinity a into e to the power minus j omega whole to the power n. So here there is a condition on a. The condition on a is mod a. Condition on a is mod a less than 1. This condition is important. Why that condition is important? Now you will understand. Recall summation n equal to 0 to infinity b to the power n is equal to 1 over 1 minus b, provided mod b is less than 1. Here what is b? B is a into e power minus j omega. when modulus of a into e to the power minus j omega shall be less than 1 only when mod a is less than 1. Very important. You apply this formula over here, that gives you x of e power j omega equals 1 over 1 minus a into e to the power minus j omega. Now we have to draw the amplitude spectrum and phase spectrum that requires determination of magnitude and phase of this expression given over here. Please note that. Note a complex number a plus jb has got magnitude root of a square plus b square. Angle is tan inverse of b by a. When you multiply, when a complex number is present in the denominator like this, what is the magnitude? 1 over root of a square plus b square. And what is the angle? Minus tan inverse of b by a. A complex number will have a negative angle. The complex number in the denominator will have a negative angle as shown in this expression. If you this is called polar form representation. Let us multiply two complex numbers in polar form, m1 at an angle phi 1 with m2 at an angle phi 2. The result is m1, m2, magnitudes get multiplied, angle gets added, phi 1 plus phi 2. On the other hand, if you divide two complex numbers in polar form, like m1 at an angle phi 1 divided by m2 at an angle phi 2, you get the magnitude as m1 by m2. Take this angle phi 2 to numerator, it becomes minus phi 2, and add it to phi 1, you get phi 1 minus phi 2. All these aspects you have studied in your first year basic electrical course. Just for the sake of revising, I have told these fundamental things. Now these aspects are to apply to this expression. What is the magnitudes? What is the magnitude? We know that e to the power minus j theta is what? Cos theta minus j sin theta. This is the best way. Then what happens? Xf 1 over 1 minus a. What is e to the power minus j omega? Cos omega minus j sin omega. This is simpler to understand. So this is 1 over 1 minus a cos omega, real part, plus j sin omega. Please follow this. This is the real part, the imaginary part. Hence, magnitude of x of e power j omega equals 1 over real part square. That means 1 minus a cos omega whole square, real part square, plus imaginary part square. This gives the magnitude. What is phase? Phase is theta omega equals a complex number is in the denominator. Therefore, the angle is minus tan inverse of imaginary part, which is sin omega, divided by real part, which is 1 minus a cos omega. So what I have done? E to the power minus j theta, I have written using de Moivre's theorem as cos theta minus j sin theta. Then I have collected the real part and the imaginary part. Magnitude is
here sin theta.
Okay. Here also sin omega gets multiplied by a. So this becomes a into sin omega whole square. So a into cos omega, a into sin omega. Thank you. So now I am going to plot it now. Here also a sin omega. Okay. Now I will make a small table. This is omega. This is magnitude of x of e to the power j omega. This is theta omega. I will always plot these values from minus pi to plus pi. Minus pi by 2, 0. plus pi by 2 0. I again repeat, this a gets multiplied, a multiplies cos omega as well as sin omega. Therefore, we get this expression. This is the real part, this is imaginary part. Magnitude is square root of real part square plus imaginary part square. Angle is minus sign because the complex number denominator. Tan inverse of imaginary part, which is a sin omega, divided by real part 1 minus a cos omega. The magnitude spectrum and phase spectrum are periodic with a fundamental period equal to 2 pi. Therefore, we take omega values from minus pi to plus pi, signifying that we have taken an interval of 2 pi radians. In this expression, you put minus pi. What is cos of minus pi? Cos of minus pi is minus 1. Sin of minus pi is 0. So what you get when you do that? You get the expression 1 over 1 plus a. When you put minus pi in this expression, cos of minus pi is minus 1, sin of minus pi is 0. When you put plus pi in this expression, you get 1 over 1 plus a. Since x of n is a real signal, magnitude of x of e power j omega should exhibit even symmetry. Therefore, what value you get at minus pi, same value you have to get at plus pi. In this expression, when you put minus pi by 2 or plus pi by 2, sin of minus pi by 2 is minus 1, sin of plus pi by 2 is 1, cos of plus minus pi by 2 is 0. So you get the expression 1 over root of 1 plus a square. You put minus pi by 2, cos of minus pi by 2, 0. Sin of minus pi by 2 is minus 1. Minus a whole square is what? A square. Cos minus pi by 2 is 0, therefore in this bracket only 1 survives. If you put plus pi by 2, you get the same expression. The value at minus pi by 2 and value at plus pi by 2 will be identical because magnitude of x of e power j omega exhibits even symmetry when x of n is a real signal. Then you put omega equal to 0. Sin 0 is 0, cos 0 is 1. So you get 1 over 1 minus a. 1 over 1 minus a. Next we come to this expression. If you put omega equal to pi, sin of minus pi is 0. Tan inverse of 0 is 0, therefore this angle is 0. When you put plus pi also 0. When you put minus pi by 2, please watch. Sin of minus pi by 2 is minus 1. Cos of minus pi by 2 is 0. Tan inverse of minus a. See what you get here? You get minus tan inverse of minus a, which is nothing but tan inverse of a. When you put omega equal to pi by 2, you get minus tan inverse of a. Because sin pi by 2 is 1. These two angles are equal and opposite because theta of omega exhibits odd symmetry. When you put omega equal to 0, you get tan inverse of 0. Tan inverse of 0 is 0. An odd signal should be always 0 at the origin. I repeat, these values are obtained by making use of these values in this expression. These values are obtained by making use of these values in this expression. This column must exhibit even symmetry about omega equal to 0. This column should exhibit odd symmetry about omega equal to 0. And these symmetries will be valid only when x of n is a real signal. Now I am going to plot it. X-axis is omega, y-axis is magnitude of x of e power j omega. This is 0, omega pi by 2, pi, minus pi by 2, minus pi. When omega is 0, please note, mod a is less than 1. That means 1 over 1 minus a is greater than 1 over 1 plus a. When omega is 0, the value is 1 over 1 minus a. When omega is plus pi by 2 and minus pi by 2, the values are what? 1 over root of 1 plus a square. When it is pi and minus pi, the value, what is the value? 1 over 1 plus a. All these points draw by a smooth graph, the resulting curve is called amplitude spectrum. This figure is periodic. This is amplitude spectrum. This spectrum is periodic with a fundamental period equal to 2 pi. Fundamental FP means fundamental period equal to 2 pi. I have shown this spectrum only over one period. Actually, spectrum extends from minus infinity to plus infinity. But the spectrum is shown only for one period equal to 2 pi. Therefore, we have plotted this figure from minus pi to plus pi. This spectrum exhibits even symmetry. Next, I am going to plot phase spectrum. X-axis is omega, y-axis is theta of omega, omega 0. This is pi by 2, pi, minus pi by 2, minus pi. When omega is 0, the value is 0. When omega is pi by 2, it is minus tan inverse of A. This is pi by 2. When it is minus pi by 2, what is the angle? It is plus tan inverse of A. When omega is pi, what is the angle? 0. Minus pi, 0. All these samples is drawn by a smooth curve. The resulting curve is called phase spectrum. This is phase spectrum. Phase spectrum. Even the spectrum is shown for one period only. It extends from minus pi to plus pi. Both these figures are periodic with a fundamental period equal to 2 pi. This is how we have to find DTFT of a signal. We have to sketch its amplitude spectrum and phase spectrum. And this problem normally in the examination will carry 8 marks. With this, we stop.